This section is on 1.6, which is on angles, naming them, recognizing different relationships between pairs of angles, and using the angle addition postulate. First thing we're going to talk about is what makes an angle. You have an endpoint called the vertex, and then the two rays that come out of it. We name angles using several different methods. One is using 3 points. So normally there will be letters here. This might be a B, an A, and a C. So you would name this angle BAC, or you could name it, and then this is the angle symbol, or you could name it angle CA, whoops, CAB. You always keep the vertex letter in the middle. If it's the only angle in the picture, as this is, then you can name it just by the vertex. So it would be okay to name this one angle A. If there was other angles coming out of it, for example, here, you couldn't name it angle A because I wouldn't know whether you were talking about this angle or the entire angle. So you can only use A if that's the only angle that can have that vertex. Okay. Another way to name the angle is in your book. A lot of times there'll be multiple angles, so they'll use a number. And it's not the degrees, but they'll name this like angle 1. So then one way that you could name it would be name it angle 1. That would be another appropriate way if they're numbered in the picture. When you classify angles, some of the relationships, this should be a review. If it's an acute angle, less than 90, this one would be an example of an acute angle. You can see it's less than 90 degrees here. A right angle is 90, obtuse is between 90 and 180, a straight angle is 180. Anything bigger than 180, any angle bigger than 180 is called a reflex angle. We don't talk about those very much in this section, in this book. Some other more important relationships between angle pairs is complementary angles. Notice it's spelled with an E, not an I, so it's not like, hey, you look nice today. Complementary angles are two angles that when you add up their measures, it equals exactly 90 degrees. So in other words, if I put these two angles together, they would make a perfect right angle. They can be adjacent. Adjacent means they're next to each other, or they don't have to be. So it could look like this. These would be complementary angles, or it could look like this. These would also be complementary angles. These would be adjacent. These would be not adjacent. The definition of adjacent is down here. So that's just two angles that share a vertex and a common side. So you can see that this would be adjacent, this would be adjacent, this would be non-adjacent. Supplementary is same type of thing, except that the two angles add up to 180, which means together they make a straight line. Notice if I slid this angle over, it would make a perfectly straight line here. 180 degrees makes a line. Again, these angles can be non-adjacent like this, or they can be adjacent. If they are adjacent, if they look like this, where it's just a straight line with a ray coming out of it, those are also supplementary angles, but we would call those a linear pair. If they are adjacent and supplementary, then we call them a linear pair. The next one, vertical angles. Vertical angles make an X. So you can see there's an X here, and they're the angles that sit on opposite sides of the X. So this angle and this angle would be vertical angles. And if I can do something different here, this one and that one would also be vertical angles. The rays go in opposite directions and form an X. So these are vertical angles, these are vertical angles. We'll learn in the next section that these will always be the same measure. These two will always be the same number of degrees, and these two will always be the same number of degrees. The last one is just congruent angles. They just have to have the same measure. They do not have to be the same size because the rays go on forever. You could draw a little tiny right angle like this, as long as it has the right angle square in it, okay? And then you could draw a great big right angle, those would be congruent angles. They're the same measure, even though they look like they're different sizes. It's the angle measure that counts. If you need help using the protractor, I will help you. Just one of the things that you need to know if you're going to use a protractor to measure an angle, make sure that you put the vertex on the little crossbar down here in the center, and then line up one of the edges of the angles, and then you just measure up. Now, if I were to, let's see, make this bigger. Okay. Notice that there's two different sets of angles here. I can either look at this and say, okay, it's 75 because the angle or the ray hits between 70 and 80, or I can say that it's 105 because it sits between the 100 and the 110. You always start with the one that's a 0. Okay, so the arrow's pointing at the 0 here, so this is the one I'm using. If the angle was facing the other way, then I would have used the outside, because that's the outside one that starts at 0. Common sense should also play in here. When you look at this angle, if I move this out of the way, oops. If I move this out of the way, does that look like more like a 75-degree angle, or does it look more like a 105-degree angle? It's less than 90, so it's a 75-degree angle. That's the other way that you can do it. When you go to classify them, you can use a protractor. For our purposes, you can pretty much look and guess from here. This one would be acute. This one would be obtuse. Okay, and then use your protractor to measure them if you need to. As far as the vertical, supplementary, complementary, congruent, adjacent, all those things, those are all, you have to look at the picture. If you look at angles 1 and 3, and notice that 1 and 3 make a straight line. When you put them together, they make 180 degrees, so we would say that they're supplementary. They are adjacent, so in theory, they'd be a linear pair. Since they're a linear pair, they would also be adjacent. Notice that they share this side. Angles 1 and 2 sit across from each other in the X, so we know that 1 and 2 are vertical. Because they're vertical, they would be the same measure, so they would also be congruent. I'm going to use the symbol for congruent that we learned in the last section so that it's easier for me to write. 3 and 4 would be exactly the same. 3 and 4 are on opposite sides of the X, so they are vertical, which means that they are congruent. Notice vertical angles aren't adjacent. They don't sit next to each other. They sit across from each other. In this picture, angles 5 and 9 are adjacent. They share a side, and they are complementary. So complementary and adjacent. 6 and 8, notice that this is a right angle. Angle 7 is a right angle, and they form a straight line here. So 8 would also be a right angle, and 6 would be a right angle. That's how we knew that 5 and 9 were complementary. If one of these is 90, then they're all going to be 90. 8 and 6 would be vertical and congruent. They would also be supplementary because they would add up to 180. And angles, I suppose I should write that in, huh? Supplementary, congruent, vertical. 7 and 8 form a linear pair, so they are supplementary and adjacent. Linear pair, supplementary, and adjacent. The last thing we're going to talk about is the angle addition postulate. It's very similar to the segment addition postulate that we looked at in the last section. Remember, segment addition said that if you add a segment to another segment, you get a bigger segment. The picture looked something like this. And it said if you take the length of this segment and add it to the length of this segment, it has to be the same as the length of the total. Angle addition says exactly the same thing about angles. It says if you take angle ADB and you add it to angle BDC, that would have to be congruent to the angle ADC. They're measures If you add this measure and this measure, it would equal the measure of the whole thing. How we're going to use that, for example, right here, if the measure of angle ADB is x, so if I make ADB x, and I make the measure of angle BDC 62, and I make the measure of angle ADC 107, I want you to find the value of x and then the measure of ADB. Okay, so I would say that the x plus 62 has to equal 107 using this concept, using the angle addition. This angle plus this angle equals this angle. And then it becomes an algebra problem. So you would simply take 107 and you would subtract 62 from it, and that would give you 45. So x would equal 45. And that would mean the measure of ADB equals 45. There are some more examples here, same concept. This one I think you can figure out. This one, let's do this. Notice it doesn't give me a total, but I can see that these two angles are a linear pair. They add up to 180 degrees because they make a straight line here. So I would say 3x plus 4 plus 5x plus 16 equals 180, and I would do the algebra from there. So 3x and 5x is 8x. I would add the 4 and the 16 to get 20. I would subtract the 20, and then I would divide by 8, so x is 20. So I know that the value of x is 20. If I needed to, then I could plug the 20 back in and get the actual measures of the angles. So 3 times 20 would be 60, plus 4 would be 64. 5 times 20 is 100, plus 16 would be 116. And I can check myself, 64 plus 116 should equal 180, and they do, so I know I did the problem correctly. This one, same thing, ADB. If they don't label it in the picture, I would put it in the picture if I were you. ADB is 2x plus 10. It allows you to see how the pieces go together better. BDC is 3x plus 5. And then ADC, the whole thing, is 10x minus 5. So I would say 2x plus 10 plus 3x plus 5 has to equal 10x minus 5. And then I would simply do my algebra like I did up here. Put your like terms together and solve for x. That's the end of this video. Please check your pacing guide for your assignment.